Hello, everyone, and welcome to today's Hack3D webinar. My name is Gary. I'm a PhD student here at NYU Tandon in the Mechanical and Aerospace Engineering Department. So I joined the PhD program in 2019, and my research is focused on designing security features for additive manufacturing. And I'd like to welcome everybody here joining us today, and for those of you who will be watching the recording. Today, I just wanted to talk about the introduction to Hack3D. We have the summer challenge coming up within 2 weeks. So giving you some background information on the Hack3D competition, the research that we are conducting here at NYU, as well as what are the resources to help you better prepare for the upcoming competition. So to start off, I would like to welcome everybody to introduce the organizers. So we have Professor Nikhil Gupta, who is a professor at the Department of Mechanical and Aerospace Engineering. And he is the faculty lead for the Hack3D competition. And Professor Gupta was one of the very first faculty to recognize the issue of looking into the cybersecurity aspect in manufacturing. So he teamed up with NYU Center for Cybersecurity to work on the research that goes behind it, as well as introducing the Hack3D competition, where we can show our work as well as promote more awareness in this area of research. We also have Dr. Hammond Pearce, who is joining us as a postdoc lead in the competition. And Dr. Pearce received his PhD from the University of Auckland in the area of computer science engineering. And he is working with the NYU Center of Cybersecurity to look into security of embedded systems, as well as specific for additive manufacturing. And I'm Gary, so I'm one of the coordinators, and I have been coordinating the competition for Hack3D since 2019. And if you ever had the chance to take a look at one of the past challenges or the warm-up challenges, I was involved in designing all of that. And I also like to give a big shout out to all of our undergraduate researchers this year. And this summer, we were fortunate enough to have a US-India program where we invited a total of 20 students to conduct research with us. So we have 9 students from US participating institutions, as well as 11 students from India institutions. And a lot of this cohort has come from a lot of different backgrounds, not just mechanical engineering. We have computer science, chemical engineering, computer engineering. So this is a great opportunity for undergraduate students. Every single year in the summer, NYU offers a summer research program where undergraduate students can join us. So as part of the summer program, they are also helping us organize the Hack3D competition, as well as developing the mini challenge. So I thank you all of the undergraduate researchers, as well as it's a great opportunity for undergraduates to partake in the research that are occurring in the university labs. So Hack3D general overview is our competition started in 2018, and it is one of the many competitions for the NYU CSAW event. And the CSAW event is one of the largest student-led cybersecurity event that we have every single year in the fall. So for Hack3D, our competition focuses primarily on cybersecurity in additive manufacturing. So when we look and think about additive manufacturing in the chart shown here, we have a very simple overview. So for additive manufacturing, you'll probably have to consider the design. That's your CAD models, coming up with the CAD models, and perhaps running simulation. So we have the FEA analysis, the software and the files and all the information that goes into running a simulation. And perhaps there's going to be multiple iterations and a lot of back and forth between redesigning your model, running the FEA simulation, and generating the different iterations until you have an optimized design. From the CAD, from the simulation, the next step in the process would be outputting it to an STL file, which is a very common manufacturing file that manufacturing would require, and use that to help them fabricate the part. So we also have the design information in terms of an STL file format. From there, you might take the STL, import it into a slicer program like Hira, where we are generating the specific layer heights as well as the printer properties needed to fabricate the part. And from there, you would have the G-code information, and the G-code is another type of file within the process that helps us with the instructions that the machine can read. And the actual 3D printer for the additive, within the additive manufacturing process to create the part. And once you have the part printed, you might have some post-process, for example, taking CT images of the design as well as the non-destructive evaluation. And when we consider this very simplified additive manufacturing process, right, we are interested in securing this process. And that's where the Hack3D competition comes into play, where we have a lot of different challenges that will touch on one of these processes, whether it's the CAD design, STL, right, the G-code file, the actual 3D printer simulation. So the focus, as I just mentioned, is in the additive manufacturing process. So a lot of our challenges, you might find yourself reverse engineering the design, looking at, deep within the file, the code. So a lot of combination between software and hardware, because when we look at the additive manufacturing process, we can describe it as a cyber physical system where we have both cyber domain as well as physical domain. Cyber domain consists of all of the softwares, design files, and physical domain where we have our computers, machines to process all of that data as well as manufacture the part. So ever since the competition started in 2018, we have grown. Every single year we see an increase in participation, and as well as more teams internationally joining our Hack3D competition. So for the past 2 years, it has been purely, our competition has been virtual, but in the past, we have invited finalists to our NYU campus to conduct the CSAW event. So for this year, we have a phenomenal registration of over 300 plus teams to compete in the upcoming summer challenge for Hack3D. And for those of you that doesn't have an engineering background or might be questioning whether this competition is right for you, in 2019, the team that took first place, Cole and Pedro, they were both undergraduate students at NYU Abu Dhabi studying computer science. So they mainly had a computer science background without any engineering concepts at all. And they used programming to analyze the challenge as well as programming to come up with the CAD model for the final challenge during that year. And through the creative approach, that's really what helped them stand out and put them on top to take the first place. So with looking into cybersecurity in additive manufacturing, we're starting to see a lot of multidisciplinary collaboration, and that's what we're like. And we've seen that has helped a lot of teams to kind of come up above, having this collaboration between the different departments. And so when you are thinking about your team, we can kind of consider that as well as last year's competition. For those of you that are overseas, international, in last year's 2020 Hack3D competition, we have 2 teams from Indian institutes that was joining us as finalists, and 1 team from MNIT was able to take 2nd place. And this is a team from India, DC War Story, team of 2. So we are very excited about the Hack3D competition and how it has grown over the years. And we hope that through our challenges to kind of continue to promote that awareness and get more international participation. So one thing I do want to touch on and go over is the background information of what goes into Hack3D and how it all started. So when we are looking into researching the security in manufacturing, we want to ask us a very simple question of what can go wrong in the process, right? So earlier I showed you a very simplified process of the AM process chain, but I can develop it in another way shown here to show a much more elaborate version of all of the process that goes on when in the additive manufacturing. So when we look at this, we can see that all the engineers and people that get involved, as well as the design files that are involved from CAD to STL to G-code, right? All the machines that are involved, the computer, the servers to process and store the information, the actual machine, whether it's a 3D printer, CNC machine, and how everything is connected to each other, whether we are communicating through emails, right? How are we sending those design files? We have to look into all of those aspects, right? How are those files being stored? Is it on a server, local computer? And by looking at the entire AM process chain, we can start to consider, right, where can things go wrong, right? If somebody were to have a malicious intent, right, which design file, which process will they interrupt and cause some sort of destruction? So that's really where it all started here, where we look at the manufacturing process, look at all the people, machines, the cyber domain, physical domain, everything that gets involved, and we try to analyze the entire picture before we dive deep into a very specific case scenario. So in my line of work, right, when we considered the threat analysis, then we can start to think about how we can protect those design files. How can we, right, protect our intellectual property, prevent counterfeit, and all of those. And in the Hack3D competitions, each challenge tries to analyze a very specific approach and threat taxonomy in respect to that. So when we consider what can go wrong, we can categorize these threats into 4 different groups. So the first being a side channel attack. When you have these physical processes, imagine your laptop, your computer, they would give off information under operation. So for example, if I'm typing on my keyboard, as I'm typing, I produce a sound. the motor running will produce a sound in the 3D printer. So there is the effect of side channel attacks where I'm analyzing these outputs of the sounds as I'm typing, the noise that is generated as the 3D printer is operating, as well as looking at the power consumption. So all of your machines, computer, 3D printers would have a power consumption. Are we able to analyze that and provide some sort of feedback on what that machine is performing, or relating the acoustic data to the design data? And so that categorizes as a side channel attack. And as a hacker, I don't even need to infiltrate into the company. Perhaps I can just have a cell phone next to the machine, and it's recording all of this acoustic data. So the next category is direct sabotage. And direct sabotage has in mind the ultimate goal of just causing damage, whether you're causing damage to the machine or hacking into the network, gaining access to all of the design files and manipulating the design files. So the end produced part will have some sort of defect and cause it to have a failure. So that is our direct sabotage category, specifically causing some damage during the additive manufacturing process. Reverse engineering has to do with the growing popularity of not only 3D printers, as well as 3D scanners. So 3D scanners allows you to very easily take any consumer product, scan it with a cell phone or scan it with a dedicated handheld device, and it'll generate a point cloud or information, enough information for you to be able to reverse the original design and perhaps steal it to use it in your own design or create a counterfeit part. So with all of these threats, right, there is the advantage and disadvantage to it. And in our research, we are looking to provide countermeasures for some of these threats. So the last category is counterfeit production. So stolen files that are publicly available, uploaded online, available for everyone. And that touches on, right, protecting your own company's IP, intellectual property, right? How can we protect that, our design, from counterfeit production, and preventing somebody from making our design publicly available. And the threat, simple case scenario would be, what if an employee steals your design file and shares it with competitors? That will cause, loss to the business. So when we look at these threat vectors, right, we now know, right, and we categorize into these four categories of what can go wrong, and we can develop a more elaborated map and look at the attack taxonomy, right? So identifying what is the motivation for a hacker to be able to infiltrate a company, steal information, right? And looking into, once you have the motivation, what would be your attack method? Are you going to hack into the network, or perhaps you're going to bribe somebody to steal information from a company? So considering all the possibilities of attack vectors, side channels, right, tampering with data, or just simply theft. And we can look at, once they have the method, right, where in the additive manufacturing process are they specifically targeting? Are they interested in the CAD file, STL file, G code? And right, since I showed you the additive manufacturing process, right, where are they targeting specifically? And by analyzing the motivation, the attack vector, and their target, we can individually analyze each of these cases and come up with a countermeasurement. So this is right, where we consider a specific case scenario and develop a security feature that will hopefully prevent that attack from happening. So there's a lot of research that goes on in looking at watermarking for 3D printed parts, right? Creating fingerprints, embedded codes is something that we've looked on that I'll talk about. And for the Hack3D challenges, once we have a map for the attack taxonomy, we can use one of the challenges and through the Hack3D competition to kind of crowdsource all participants to help us develop, whether something is effective or not, and open the doors for everybody to contribute their creative solutions to the Hack3D challenges. So since 2018, we have a few challenges, and I'll show you later where you'll be able to access those challenges if you want to take a look and try to solve it, get an idea of what the challenge is all about. But each of these challenges can be mapped to a very specific attack goal, attack method, and attack target, and what we hope to implement in the challenge as a countermeasure. And so that's where, right, we take the research and kind of put it out as a Hack3D competition to crowdsource and to help us analyze these countermeasurements that are being implemented into the challenge and how well it works out. So from the past years, we have a lot of different participants of various backgrounds, not just engineering, perhaps computer science, machine learning, joining us for the Hack3D competition. So it's been very exciting to see the growth in the competition this year. So a little bit more specific about the research is very early on, as an engineer, when you're doing design work, you most likely want to be working very closely with the machinist, because in CAD, in design, right, you can design a lot of complex models, but that doesn't necessarily translate to something that you can make, something that you can manufacture. So similarly, you have to work closely with the machinist, right? And you have to ask the machinist, right? Can you manufacture this? Can you produce this if I design it this way? So similarly, if we consider the security aspects, there might be certain features that we can implement in the design, whether it's the CAD or STL, that when it gets 3D printed and produced, we can see the differences between the final product and the original design in CAD. So on the left, what we have here is a STL file, but in the original CAD file, we implemented a spline feature, which is a freeform curve. So we place this freeform curve onto the surface of the model, and in CAD, it shouldn't have any effect, create any gaps. But due to the export to STL, it's trying to tessellate it with all of these planar triangular surfaces. That's where we start to see the induced gaps, and it eventually translates into a defect in the actual printed part. So looking at the CAD to STL file translation, are there certain features that we can implement in the CAD file when it is being produced by the 3D printer? There is some discrepancies, and we can analyze that and kind of further look into it to use it for the purpose of security. We have also looked into, because of additive manufacturing and the advantage of the layer by layer production of the part, we can look into embedding surfaces or embedding bodies into our files, and how will that translate over. So on the right just shows you some of the very early work of just taking a simple sphere, embedding it to see how the 3D printed part will translate that, and how modifying the CAD or the STL would produce a completely different part. So from that research, it has grown into looking at embedding codes within the part. So we do have a paper on this where QR code, you'll typically see that on packages. A lot of people are sharing the QR codes to links to their web page where you can scan your phone. The phone will recognize it and it'll take you to a very specific web page, or sharing your information within a QR code. So we can take the same concept, but QR codes are typically 2D. So for our work, we're converting a 2D QR code into something that is 3D, and something that we can incorporate and embed into our designs. So on the top right, you'll see that if you imagine a QR code, you take each pixels of the QR code, create a little 3D model cube, and each of these cubes, we can explode it in 3D space. And when we explode it in 3D space, there's only one particular viewing orientation where I'll be able to scan the code as shown in image B. If I look at the code in any other orientation, it will just give me something that I won't be able to scan. So when we take a QR code, convert it into something that's 3D, embed it into our file, we need to be able to view it in a very specific orientation to be able to scan the code and get the information that is stored within the QR code. As well as specifically for the additive manufacturing process, when we 3D print our design in the slicer program, we can choose which orientation that I would like to place my part in the print bed. So depending on how the orientation on the print bed of your design is set, right? Some of the codes might be eliminated. You won't be able to get a scannable code. So another aspect to this is being able to correctly determine and lay your part on the print bed in a very specific, correct printing orientation to be able to generate the full code that is scannable. So that is the work that we have done in the past, looking at QR codes, embedded codes of these, and we've published a few papers on this as well. So we have also kind of used that in the past Hack3D challenges as well. So in 2018, one of the Hack3D challenge was participants are given a point cloud file. It is a text file that contains all of the XYZ coordinates of individual points. And point cloud would usually come from scan data. So scanning the design, and it would give you the result of a point cloud data. And students were asked to reverse engineer the original design based off of the point cloud. And the point cloud may come with a lot of noise from the scan. So it was up to participants to try to figure out what's the best way to remodel it based off of the point cloud information. In 2019, we had a chess piece challenge where students are given a G-code file, and the G-code file is damaged. So the chess piece, the top half of the chess piece was cut off, and in the G-code file, there's only the bottom portion of the chess piece. So the idea here was students have to reverse engineer the chess piece based off of the G-code file, and the G-code can give you information about the printing parameters as well as the toolpath. So students have access to all of the toolpath information from the G-code, and they had to reconstruct the chess piece and determine out of the 3 available chess piece possibilities, whether it's the pawn, bishop, or queen, which one would be the correct chess piece. And of course, within the G-code, we have this embedded code that you can see on the bottom left. And one of the things that had to be determined was figuring out that this was an embedded code and not just any noise. And participants had to view it in a very specific orientation to generate this QR code orientation and make it out as a QR code. But then once you know that it's a QR code, you still had to process that to be able to get a scannable QR code, which will take you. So within our challenges, a lot of times we like to embed puzzles that participants will have to solve. So that's one of the puzzles that's embedded into the chess piece challenge file. In 2020, we took a typical light bulb CAD file and we just saved it in a very obscure way, which is just taking all of the slices of the silhouette to the light bulb file. So taking a light bulb model, converting it to only represent it as all of these 3D sketches base, which represents the silhouette of the light bulb. And based off all of these 3D sketch slices of the model, we have to reverse engineer the original CAD. And once again, we try to incorporate within our challenges, some alternative approach, some puzzles. And within the light bulb where the filament is, we've incorporated a very specific puzzle piece that provides an additional way to solve our challenges. Perhaps when looking at it, whether you're engineering or computer science background, we like to incorporate a lot of network security elements and different elements from different disciplines into our challenges, so we can open up our challenges to more disciplinary backgrounds. So later on, I'll show you where you can have access to all of these different challenges if you do want to take a look at them and try it out with your team. Besides the main challenges for the event, we also have warm-up challenges and mini challenges that we'll like to put out during the registration period. So on the left is last year's warm-up challenge, where the first one is a 3D jigsaw puzzle, and the second one is a puzzle. I can stop my screen to share that. So the first puzzle here, and these warm-up challenges, the idea is to help participants get used to the file formats that might be used in challenge, and it can vary from any file format that exists in the additive manufacturing process. So this one is specifically an assembly file, and it is a jigsaw puzzle of a basketball with, on each piece of the puzzle, there are logos and markings to help you piece them together better. And from here, in the sea of 3D jigsaw puzzles, you have to use assembly mates or join them together piece by piece to form the basketball. So this is one of the challenges that we have proposed in the past. Just a nice quick warm-up challenge for users to get used to the file and the ideas that we like to incorporate into our challenges. The next one is more of a mind puzzle game where we have this grid, and each square on this grid is color coded. So you have to determine what is the pattern in this challenge. So figuring out what the pattern is and decoding this color code challenge and filling in the center row with the color that you think best fits the center row. So simple enough, we just have to decode the puzzle that exists in the colors and fill out in the center row what we think the color is. So going back to my presentation. Okay. So this year on the right, our summer research students have come up with some mini challenges that you might have already seen if you are in our LinkedIn group. And I'll share that with everybody later on. So there are already 2 mini challenges that are being proposed. The first one being a STL file and being comfortable with understanding the STL file and how to manipulate them, as well as a Monomania challenge created by our group to look at the CAD programs and figure out the challenge, perhaps with different method. So we really like to see within these challenges the creativity that the participant comes up with. Most of the time, there's not only just one solution, but a team might come up with a completely different solution to give us, the organizers a surprise on how it was being solved. So we really like to see that, and that really comes with, matching up with students of different backgrounds, creating a team of multidisciplinary where everybody can share their experience and their ideas in how to approach these problems. So let me take a quick break here, and you can see that we have the following resources, which I'll touch on in a little bit. So the first one being, if you're already registered for our event and you're placed into teams, we have the group sent out an email to everybody where you can join our LinkedIn group. So the LinkedIn group is where we can provide everybody with updates, as well as you'll find the challenges there. Any updates regarding the Hack3D competition that's coming up, as well as the LinkedIn group is there to help you form and connect with each other to form teams. If you are looking for a team or you would like to reach out to other students to connect and work on the challenges together, the LinkedIn group will be a great way for you to do that. So if you're already in our LinkedIn group, if not, you can join. I'll share the link in the chat with everybody, or perhaps Hammond can post it to the chat. But in our LinkedIn group, Caleb, one of the leads in the mini challenges, have posted both of the challenges for you to complete and try on your own. And we have been posting regular updates to the challenges as well. So it's a great way to connect with each other. And if you are looking for a team, feel free to join our group and create a post to help you better connect with each other. I know from the registration list, many of you have formed teams already, but perhaps there's still a lot of you that are looking to connect with each other, to form teams, which will better help you participate in the upcoming challenge. So definitely check out our LinkedIn group. I would post the recording and my PowerPoint presentation to the group. So if you do want to have access to that, you can join the group using the link. Next is the Eventbrite registration page. So this is where you can register your team and join teams for the challenge. And for those of you that are registered, you've been receiving regular updates from the team about our competition and the resources available. So once you have formed your team, feel free to register. When you register, one thing I do like to point out is you have the option to join a team as well as create your own team. So you are able to, after create your own team, if you want to collaborate with other individuals, join their team, you can do that. But there is one limitation to the Eventbrite site, and that is if you create your team, Eventbrite doesn't give you a way to delete your team or delete your team's homepage. That would be something that is not under the control of the organizers, and perhaps you can reach out to Eventbrite about that. But let's say that you have created your team. If you want to join another team, what you would do is in your registrations, you would cancel your previous registration and just register again, indicating your new team. Okay. So in your personal homepage, you'll still see your old team website. But as long as you canceled your old registration and register yourself to the new team, that would resolve the issue. Okay. And hopefully, as I'm going through this, it clarifies some of your concerns. If not, you can post them to the Q&A and we'll take a look. So the next place for research is our Hack3D homepage. And I mentioned that Hack3D is one of the competitions, part of the global CSAW event that takes place in the fall, which is a large cybersecurity event with a lot of student-led competition. So all of our competitions are student-led. So in our Hack3D homepage, there you would find much more resources. So the summer challenge, the link to the Eventbrite page where you can register your team and look at the rules. One thing I do want to point out is you'll also find our research paper on Hack3D. So if that is something of interest to read, to understand the competition more, as well as looking at the write-up for the previous challenges, this will give you a lot of insight of what goes into our competition and the reason, background information of why we're having this competition, as well as the resource. So there is the Hack3D paper. That'll be a great read. If you want to familiarize yourself with the competition. So moving further down, the warm-up challenges are available on our webpage. It will just take you to the Drive link. So within these challenges, you can access the challenge where you can solve on your own. Within the Google document, you also find the solution. So there will be a solution folder within that. So if you want to take a look to see the method or whether you did it right or wrong, the solutions are provided as well. If you are interested, besides the warm-up challenges, to look at our previous main challenges for the Hack3D competition, there is a 2018-2020 challenge repository, which takes you to the GitHub. And within the GitHub, you will be able to locate the main challenge for each year. And you can try that on your own with your team. So that you can look at, what goes into developing these challenges and gain a little bit of experience. So we do have a little less than 2 weeks for the competition. So hopefully you have a chance to download and look at the challenges to help you better prepare. And that's pretty much it. So our LinkedIn group, most of you have joined it. See a good list of students. So feel free to come post, introduce yourself if you would like to connect with the rest of the group. We have our LinkedIn group, your registration page where you can register your team and participate. We'll be sending out the challenge on the 26th. So you have 1 week for the preliminary challenge, and you have time before that to look at all the available resources and try the challenge or no. As well as our main Hack3D webpage, where you can look at the previous warm-up challenges, the paper published on Hack3D, as well as the previous main challenges repository. So you have access to all of that there. So that's all I have. I'll go ahead and post the link to these resources so you have that. I'll post that to the chat. So you have the link to each of the resource available to you. As well as I'll share it. So let me see if there's any questions or if we have addressed it all. Okay, I don't see any new questions coming in from the chat or in Q&A. So I'll go ahead and conclude today's webinar. And thank you so much for joining us. And thank you for those who are watching the recording. So we will be sending out updates as well as posting them to our LinkedIn group for the upcoming Hack3D Summer Challenge. So be aware of that. And thank you everybody for joining me today. Best of luck in the Hack3D competition. And I look forward to seeing all of the submissions that you may have. So thank you once again.